Hey everybody, this video is going to talk about something called the determinant. And the determinant is just a special number that we calculate for square matrices. Okay, it has to be a square matrix, meaning the number of rows is the same as the number of columns. So here's how we actually calculate this, and we're going to use this down the road when we start calculating inverse matrices. So to find the determinants, typically, first of all, you're going to be seeing this notation. It kind of looks like absolute value bars, but it's not. For a matrix, if you see those bars on the side, not the brackets, but those straight vertical bars, then you're going to be taking the determinant of that matrix. And for a 2 by 2 matrix, what we're going to be doing is we're going to be multiplying these values together and then subtracting the product of these values. So it's going to be A times D minus B times C. So I've got two examples here. So I'm going to be calculating the determinant of this matrix inside. So we're going to do 5 times 9 minus, and then we're going to do 8 times -4, or -4 times 8. The order doesn't really matter. Okay, so we get 45 minus, and then -4 times 8 is a -32. So we really have 45 plus 32, which is going to give us 77. Okay, so let's look at another one. Okay, again, we're taking the determinant, and I know that because I have these bars around my matrix. So we're going to be doing 0 times 11, or I'm sorry, -11 first. And then we're going to subtract 6 times 4. So we've got 0 minus 24, so we get -24. So those numbers that we're getting at the end that I have circled, those values are the determinant. So let's see what it looks like for a 3 by 3 matrix, because it's going to get more challenging every time our matrix gets bigger. So if we have a 3 by 3 matrix, okay, and let's say that, you know, A through I here are the elements that you see inside, then the determinant is calculated by this big old formula down here. Okay, and I know that that looks scary and complicated, but it's really not as bad as it looks. Okay, there is a pattern here. There is a method to the madness. So if you look down here at the very bottom, this is what's going to be most helpful. Okay, we're going to have 3 calculations that we're making here. We're going to do A, okay, so the first element in the top row, times the determinants of the values in that bottom right-hand corner. So notice like we're like canceling out. We're not paying attention to anything in the column that A is in or anything in the row that A is in. We're just doing A times the determinant of that bottom right corner. Okay, and then we're going to subtract B. And notice we're not paying attention to anything in the row or column of B. We're taking the determinants of what's left over. And then we're going to add that with C. Notice again, we're not paying attention to anything else in the row or column that C is in. We're going to multiply that with the determinants of that lower left-hand corner. So let's look at an example here so I can kind of help you make more sense of this. Okay, I've got my 3 by 3 matrix. I'm taking the determinants. So we're going to start off by doing 4 times the determinant of this stuff here. We're not paying attention to anything in the row or column of that first elements. So we're going to do 4 times the determinant of that bottom right-hand corner. Okay, well, the determinant of that would just be 2 times 9, which is 18, minus 6 times 5, which is 30. Okay, so we've done the first part. So let's erase this gibberish up here, and then let's go back and check our formula here, because notice that the signs change. Okay, the first go around we're going to be subtracting. Okay, we're subtracting, and then we are adding after that. So next we're going to take this negative 8, so we're not going to pay attention to anything in its row or column. We're going to be taking the determinants of negative 3, 6, negative 4, 9. Okay, that matrix with those values that are left over. So the determinant of that, and remember we're doing minus, and then we've got negative 8 times the determinant. So negative 3 times 9 would be a negative 27, minus 6 times negative 4 is going to be a negative 24. And then we're going to add, and we're going to make our final calculation here. We're going to do 3, so we're not paying attention to anything in its row or column. And then we're going to multiply 3 with the determinant of these values here. So the determinant there would be negative 3 times 5, which is negative 15, minus 2 times negative 4, which is a negative 8. So let's clean this up a bit. All right, we've got really 4 times negative 12 plus 8, right, because of the 2 negatives here. And then that's going to get multiplied with, well, we're subtracting a negative 24, so negative 27 plus 24 is really a negative 3. And then plus 3 times negative 15 minus a negative 8, so it's really like we're adding an 8 here, so we get negative 7. So let's go through again. We really have negative 48 minus 24 minus 21. So the determinant here is going to be negative 93. So it is a significant amount of work here when compared to the determinant of a 2x2 matrix. And again, the reason we're doing this is so that we can calculate the inverse of matrices later on. Okay, so that is it for this video. Let me know if you have any questions, and have a great rest of your day.